You open multiple navigators. That is the problem. N largest and N smallest. You are using N largest and N smallest. Suppose you want in between. In between means I want neighborhoods with greater than 500 entire home apartments, less than 1000 entire home and apartments. So you can see here, first we have to write the cross tabulation to a data frame. We will assign a name to the data frame D1. D1 is equal to cross tab, neighborhood and room type. Then we will slice, subsetting the conditions. We are slicing based on the conditions here. This is condition 1, greater than equal to 500 rooms, and condition 2, less than equal to 1000 rooms. Each condition is in parenthesis. Question పంపించండి నేను పే చేస్తాను. ఏం క్లెయిమ్ జరగలేదు. Okay, right. So we are slicing the data frame based on two conditions. One is greater than equal to 500 and less than equal to 1000. And is the conditional operator here. And pie chart. So with percentages, 2 decimal percentages. If you want the percentage values, you have to give 0.2, 2 decimal. Percentage 0.2, 2 decimal, percentage symbol. 1 decimal with percentage symbol. Otherwise, you will get the slices, you will not get the percentage values. So by adding the auto PCT function parameter, you are displaying the percentages. So if you say 1, you will get only 1 decimal. Data aggregation using the group by function. Using the group by function, aggregate the data. NYBNB dot price dot group by NYBNB dot room type dot mean. The left side of group by must be numerical, right side of group by categorical variable, a statistical function, standard deviation, etc. Some min, max, you can specify any of the statistical function. Aggregation or group by, we have done using pivot tables in, so it will total all the room type entire home apartment prices and divide it by the count of the home apartment. Similarly, hotel room, it will combine the sum total prices of the hotel room and divide it by count. So this is the process it will do in the back end. So basically it will take the price sum of price of all the hotel room properties divided by count of hotel room properties. This is the process it will execute for the back end. Remember the mean formula, sigma n divided by n. So we are subsetting the property types as hotel room. Then we are adding the prices of all the hotel rooms and dividing it with the count of, so you get 416.168. You can see here, you got the same mean. So same process, it will repeat in the back end for each of the categorizations and it will calculate the mean. Okay, so this is the process which I have shown you will be done iteratively on each of the categories in the back end. The group by function will first sort the data into the specific categories, then splits the data into that many data frames, and then calculates the average of the price column of each of the data frame. So this process it will do in the back end and it will give us the output. So this is the functionality of group by. Based on the categorical, split it into that many categorical variables, then calculate the average of the numerical column which you are specifying. You can show it as the group by function. New York BNB dot price dot group by NYBNB dot neighborhood dot mean sort underscore values is equal to, so Coney Island has the highest average price, followed by West Brighton, Wakefield. Okay. So answer this question. What is the average? What is the median for each average number of reviews for each room type? Median price for each room type. The numerical variable on the left side, categorical variable within the brackets on the right side, and a statistical function.
How to get 2 decimal values?
NP dot round is the function for rounding the data, numpy, and then comma 2. NP dot round is a function within numpy to round the decimals. NP dot round, give the value, comma, and then the decimal number 2. You will get exactly 2 decimals. So NP dot round output comma decimal. So the data aggregation which we have done in Excel using pivot tables, we are doing it here using group by function. Using the group by function, we are aggregating the data based on certain conditions. All of you, group by function. Okay, we will be using Melbourne housing data set. Melbourne housing data set. So we have 13 variables. This also has lot of variables. Okay, we will use bike share data set. I am sending you the data set. So this is bicycle sharing data set. Okay, I have sent you the data set. All of you open a new Jupyter notebook. Bike.data.info. There are no missing values, right? Bike.data.columns. .cnt. .describe. Descriptive statistics. Bike.data.cnt. .skew. Bike.data.cnt. Very close to 0. Bike data double square bracket CNT. So for multivariables, double square brackets, data frame name followed by double square brackets. Double square brackets. Bike data dot season dot value underscore counts. Season 1, 2, 3, 4. So I have already shared you the text file. So as per the text file, season 1 refers to spring, season 2 summer, season 3 fall, season 4 winter. 1 is spring, 2 is summer, 3 is fall, 4 is winter. Frequency of weather situation. Bike data dot weather set dot value underscore counts. 1, 2, 3. Again, 1 is clear, few clouds and partly cloudy. 2 is mist and cloudy. 3rd is light snow, light rain, light snow. This is the 3 situations. Then cross tabulation between holiday and weather situation. PD dot cross tab bike data dot comma bike data dot weather situation. PD dot cross tab. What is the next one? Bike data dot weekday and weather situation. So 0 is Sunday, 6 is Saturday. 0 is Sunday, 6 is then histogram, box plot and density curve of CNT. Bike data dot CNT dot plot kind is equal to hist. So you can see, right? Almost similar to normal distribution. Similar to normal distribution. Or I think dual peak. 2 peaks are there. Bike data dot CNT dot plot kind is equal to comma work is equal to false. So there are no outliers in our data. There are no outliers in our kind is equal to hist for histogram. Kind is equal to box. Work is equal to false for bike data dot CNT dot plot. Kind is equal to single quotes or double quotes hist. Bike data dot CNT dot plot. Kind is equal to box. Work is equal to false. There are no outliers. There are no outliers in our. Then bike data dot CNT dot plot. Kind is equal to closer to normal distribution, but not exactly normal distribution. Next, average CNT of weekday. Bike data dot CNT, the numeric variable, dot group by bike data dot weekday dot mean. So average bike demand on different weekdays. On different weekdays, what is the bike demand? On different weekdays, what is the bike demand? Which is Friday, followed by Thursday. So bike demand is high on Friday. Okay. 5 is stop. Ascending is equal to false. Okay. What is the next one? Average temperature of weather situation, right? Bike data dot temp dot group by bike data dot weather situation. So 0.51147, 0.43. Got this, all of you? Average median CNT of season. Bike data dot CNT dot bike data dot median. You want sorted dot sort underscore values is equal to false. So season 3 highest followed by season 2, season 4 and season 1. Humidity and season. Bike data dot humidity dot group by bike data dot season. Now we can give multi-categorical variables. We can give multiple categorical variables. Bike data dot CNT dot group by square bracket in group by multiple arguments always given square brackets. Bike data dot season comma bike data dot weather set dot mean. 2 categorical variables in square brackets. Multiple variables or multiple arguments we have to give in square brackets. So now you can see here, season 1, 2, 3, 4, weather situation 1, 2, 3, season 1, weather situation 1, season 1, weather situation 2, season 1, weather situation 3. Multiple arguments you have to give in square brackets. Multiple arguments must be given in square brackets. Square brackets means list or array. Yeah, it has to be one liner. So what do you observe from here? So until we sort, we don't know what is the actual thing. Sort underscore values ascending is equal to false. What is your interpretation? Most bikes are rented on an average and weather sit followed by season 2. See, when you're writing interpretation analysis, you talk about three things: down or horizontal. Interpretation. When you're looking at interpretation, if it is a line graph, you look for up, down, and horizontal. If it is a bar graph, you look for the. So when you are plotting bar graph, you should do descending order. By default, you have to do descending order sort. The higher the bar, the larger the proportion. So bars will represent proportion. Bars will represent proportion. Sometimes you also talk about percentages. So typically, when you are looking at interpretation and analysis, first, if it is or horizontal, typically line chart. How much is the change? Large bar, small bar, medium bar. You have the bar charts change, right? Percentage, proportions, or similarly, growth percentage, month on month, growth percentage, and quarter on quarter, again, proportions or percentage. In pie diagrams also, we look at the proportion and percentage. For histogram and outliers, small boxes are there. At the end, it represents for skewness, histogram and outliers. For box plot, first outliers and skewness, the position of the box, density curve and outliers, year on year, quarter on quarter, month on month. Let me see if I can give you an image, charts and interpretation. Nothing is there. Once I find, I'll send it. Okay. Bivariate statistics. Till now, we have worked on univariate statistics. Two variable, the measures of covariance points to the directionality of movement of two variables. Mathematical sign, positive covariance, both variables same direction. Negative covariance, both variables opposite direction. Points to the directionality of movement. It simply points to the directionality of movement, whether both of the variables are moving in same direction or opposite directions. So you are bothered about the mathematical sign only. We are bothered about the mathematical sign only. Positive means same direction, negative means opposite direction. Quantifies the relationship between two variables, quantifies the relationship. That means it gives you a numerical value. Correlation quantifies the relationship. That means it gives you a numeric value to the relationship. In the earlier case, only the mathematical sign is given, plus or minus. Based on that, we will do. Here we have a numerical value. Correlation lies between -1 to 1. Correlation lies between -1 to, so the correlation 0.9 to 1, very high positive correlation, 0.7 to 9, high positive correlation, 0.5 to 7, moderate positive, 0.3 to 5, low positive, 0 to 3.0, negligible. Same thing on the negative side. Hey, can you guys come tomorrow afternoon instead of Friday? Because Friday I have a guest lecture. So you guys can come tomorrow afternoon, 2 to 6, Tuesday, Wednesday, and Thursday. This only week, because Friday I have a guest lecture. So tomorrow you can come, no? No. Your exam is last week. Acha, that aptitude test, that is done by the placement guys and all. That you have on Friday only. That is not conducted by me. So you will guys come tomorrow, Wednesday 2 to 6 instead of Friday. Okay, correlation. If you are looking at bivariate plot, the relationship to variables. Bivariate plot is called scatter plot, which highlights the relationship between two variables. So scatter plot and correlation examples. No, cluster is different. Clusters are different. So these are the bivariate statistics. Till now we were looking at univariate statistics. With this bivariate statistics, we'll complete EDA. Exploratory data analysis will be over with this bivariate statistics. By data dot columns. First print the column so that you can have the column names and all the simultaneous columns from temp. These are all numerical columns. Bivariate statistics can be calculated only on numerical data. Bivariate statistics is calculated only on numerical. So in covariance, you look for positive and negative. So we have negative covariance between wind speed and humidity. So only the mathematical sign is important here.
So this covariance is with respect to each other.
So this is the covariance between a temp and wind speed. This covariance is between temp and wind speed. This is the covariance between temperature and wind speed, opposite direction. Between two variables. See, these are the same. See, the mirror values. Wind speed and temp is minus 0.0. Temp and wind speed is also same value. Actually, it's only one matrix. The other is the mirror image. Dot CORR. Copy paste the variable and the column names. Dot CORR. So you can see there are strong correlations, moderate correlations, negative correlations, and weak correlations. Strong correlation between temp and a temp. Weak correlation or no correlation between humidity and temperature. Negative correlation between wind speed and temperature. Moderate correlation between casual and temperature. Registered and temperature, casual, moderate. CNT and temperature also moderate. You refer to the previous table. See, this is the values you should look for. Got this, all of you? Diagonal values are 1, variable to itself. All diagonals are 1s. You should ignore them. Okay. See, when you have very large number of variables, observing correlations will become very, very difficult. So we use something called heat maps are used for studying in case of many variables. When you have many variables, we can't go through the matrix manually. We have to depend on heat maps. Now, heat maps are very interesting, which will help you to find the relationship based on the color. Based on the color coding, we will find the relationship. Darker the color, stronger the relationship. Light or white color, no relationship or less relationship. Darker to lighter. Heat maps will any color. It can be red, green, orange, green, or anything. Darkest color to the lightest color. Lightest color will be no correlation. Darkest color will be very strong correlation. Medium color would be moderate correlation. Now for visualizations, we use a library called Seaborn. Import Seaborn as SNS. Now Seaborn is also part of Matplotlib. Seaborn is also now part of now Seaborn as SNS. SNS dot heat map. Go to the previous command. Copy the complete command till CORR. SNS dot heat map, comma, anode is equal to true. Anode is equal to true will also give you the values. So it is going light to dark. Acha, C map will take as crest. Now we got dark to light. And anode is equal to true means it will give you the values. The values of correlation are also plotted in the graph. If you don't give anode is equal to true, you'll get only the plain graph. Anode is equal to true will also give you the values of correlation. Acha, you are getting no module names. Only you are getting a exclamation pip. You are using Chrome or Edge. Internet Edge is a problem. Explorer is a problem. So what you have to do is open Anaconda prompt. In the Anaconda folder, you will see Anaconda prompt. In that Windows icon, Anaconda folder, Anaconda prompt. Right? You got Anaconda prompt. In the Anaconda prompt, type this one. Conda space install -c here. Conda install. Conda space install -c Anaconda Seaborn. Conda install. It will install the library. Solving, it's rotating, right? After that, it will say library. You press small y and press enter. All right, all of you got this? Now, by data dot plot x is equal to CNT, y is equal to comma, kind is equal to. See, this is the scatter plot using bike data dot plot. X is equal to CNT, Y is equal to 10, kind is equal to scatter. So what is the 0.63? 0.63 moderate. X is equal to CNT, Y is equal to 10, kind is equal to scatter. Data frame dot plot. SNS dot pairs. SNS dot paired plot, scatter plots of all variables. No, not interested. So in paired plot, you will get the scatter plots and the histograms also. This is the histogram of registered. This is the histogram of CNT. This is the histogram of casual, positive skewness. This is the histogram of wind speed, histogram of humidity. So each variable's histogram and its scatter plot with other variables. The scatter plot with other variables. This is correlation 1. See, this is 1 means lot very close to 1. Temp and atemp. If you look at temp and atemp, it is 99. See, straight line means it's close to 1. We will discuss. Each variable's histogram. Each variable's histogram. Seaborn is advanced visualization. See, if you wanted to color visualizations, then we go into Seaborn. Multiple variables. See, in Matplotlib, we don't get all the variables now, we'll get only 2 variables. In Pandas plot also, we'll get 2 variable scatter plots. Right. So Seaborn and all will give us advanced variables. If you want to do multi-plots, multi-variables in one single plot, then Seaborn is the library which you need to use. It is visualization library, exclusive for visualization. If you can open the day.csv file, file, save as, format is Excel workbook. File, choose a location, save as, type as Excel workbook. Save it as Excel workbook. File, save as, then choose the location where you want to save as type, format, change it to Excel workbook, first option. So all of you go to data tab. Do you see data analysis toolpack? The data tab. Do you guys see data analysis toolpack? Data analysis is there. Right extreme triangle corner will be data analysis. You can do one thing. Go to file, options. Last, here you see sheets now. Sheets is different. One second. Go back. Did you convert it into Excel? No, I think it is converted into Excel. No. CSV will open in Excel only. Actually, product activation payments is not taking the original. Manage Excel IDs, go. Click on go below. There. Take mark the first and last. Manage Excel IDs, go. No. Go. Analysis and solver. Okay. Click OK.
Analysis toolpack and review.
Analysis toolpack and solver. Okay, in data analysis. WPS office. Open data analysis. Data tab. Go to data tab, you will see data analysis. Choose correlation. Okay. Input range. Click on the box. Select from temp. Control Shift side arrow. Control Shift down arrow. We'll select the data range. Input range. Select from temp to tick mark labels in first row. New worksheet. Labels in first row. New worksheet. Click OK. We'll get the same matrix which you got in. So data analysis, select the data range, Control Shift side arrow, Control Shift down arrow, temp, complete temp to all variables you have to select, labels in first row, new worksheet, click OK. Okay, you got the output, right? Same values what we got in Python, you get the same values here. Now select the numbers, select only the numbers. Go to Home tab, select only the numbers. Home tab, conditional formatting. Color scales, green, yellow, red, or use this one. Green, yellow color scale. Tick mark labels in first row. Tick mark labels in first row. Conditional formatting. Select the numbers only. Go to Home tab, conditional formatting, color scales. You can choose any color scale you want. For conditional formatting, color scales, you can see the heat map. Hey, Google Sheets you're able to do. So similarly, you can do covariance also. Data analysis, temp, Control Shift, side arrow, Control Shift down arrow, labels in first row, new worksheet. Exactly like correlation. Covariance. Below correlation, you see covariance. Exactly like same. Same thing you can do for descriptive statistics. Same method for descriptive statistics. Data analysis, descriptive statistics. Input range, temp, Control Shift side arrow, Control Shift down arrow. Labels in first row. Summary statistics. Confidence level. Kth largest, kth smallest. Tick mark all options. Descriptive statistics. Below covariance only you will see. Descriptive statistics below covariance exactly same. Select the complete range from temp to CNT all variables. Click OK. You'll get the descriptive statistics for each variable. Mean, median, standard deviation For each variable, you will get the descriptive statistics, skewness, kurtosis, min, max, standard deviation, variance, data analysis, descriptive statistics, select the data range,